Hello everyone, welcome to lesson 61 of our Golang course. In this lesson, we will focus on working with time in Go. So let's dive in. Before we dive into how Go handles time, let us build some background on how computer systems work with time in general. Most modern operating systems have two times, the wall clock time and a monotonic time. The wall clock time represents real world time, usually sourced from sources like NTP or the network time protocol or the user sets themselves. The wall clock time can jump forwards and backwards to make adjustments to time like daylight saving or leap years, etc. It will give you a specific time relative to a standard like UTC. Now let us go over monotonic time. A monotonic time clock is always increasing in value and never jumps backwards or forwards, unlike the wall clock. Think of it as an ever increasing counter. It is used to measure time since elapsed time, for example, an arbitrary starting point in the past, like starting up a computer system, or the Unix epoch time. In summary, the wall clock time is used when you need to know the actual time, while the monotonic time is used to measure the elapsed time without being affected by the wall clock time changes. Now let's turn our focus to the standard lib time package. Like any modern language, Go provides first-class support for working with time. This is done through standard lib package called time. The representation of time in Go uses both the wall clock and the monotonic time. The general rule of thumb, as we discussed earlier, is that for getting time for time-telling operation, Go uses the wall clock time, like the current time, while for performing time-measuring operations, a monotonic clock reading is used. You can read more about it in the time package docs. I will provide a link to it in the video description. The two main types provided by Go to work with time are time.time and time.duration from the time standard lib package. Let us talk about time.duration first. The type time.duration represents a span of time as int64 nanosecond count. This means it stores the duration in nanoseconds, the smallest unit of time in Go. This also means that the largest representable time duration in Go is approximately 290 years. The following are the duration constants defined in Go. It omits defining a day to avoid confusion across daylight saving time zone transitions. So, at the lowest level you have nanosecond, which is of type duration and value 1. Next you have microsecond, which is 1000 nanoseconds. Then you have milliseconds, which is 1000 microseconds, second, minute. So these are constants defined in the time package that you can use to calculate the duration. Let's now look at an example to define a duration. Here in our example, we are defining a duration of 2 hours 15 minutes. So you can simply do t, which is the type duration, is equal to 2 into time.hour plus 15 into time.minute. And that gives you a duration of 2 hours 15 minutes. You can also parse duration from a string using the parseDuration function, which accepts a time string and returns the duration or an error if there's an error while parsing the duration from the provided string. Since time.duration type is based on int64, you can simply use the comparison operator to compare the time durations. The time duration type also provides direct access to individual components like hours, minutes, etc. via various methods. So if we take t, which is of type duration from the previous example, we can do time.nanoseconds to get a nanosecond representation. Then we can do d.microseconds, d.milliseconds, d.seconds, d.minutes, and d.hours to get the duration in their respective units. There are other functions like since and until that take a time and return the time duration. Now let us look at the time.time type. The time type is a structure for representing a specific point in time. It stores year, month, day, hour, minute, seconds, nanoseconds, along with any location information. A time represents an instance in time with a nanosecond precision. Programs using times should typically store and pass them as value, not as pointer. This is time variable and struct field should be of type time.time, not a pointer to time.time. The sub method subtracts two instances of time producing a duration. The add method, on the other hand, adds a time and a duration producing a time instance. Few more things to note before we move on to the example. The zero value of time is January 1st, year 1st, and all zeros. A time like this is unlikely to come up in practice, but you can have zero values for time. The is0 method gives a simple way of detecting that time has not been initialized explicitly or it holds the zero value for time. Note that unlike the duration, the go equality operator will not only compare the time instance but also will compare the location and the monotonic clock reading. Therefore, time values should not be used as map or database keys without first guaranteeing that the identical location has been set for all values, which can be achieved through calling the UTC or local methods on the time instance and then removing the monotonic clock reading by calling time.round and providing a value of 0. Time instances can be compared using before, after, and equal method, which is the recommended way. Now that's enough for the theory. Let us go into the code example. Here in our main file, the first thing we do is to get the current time. To get the current time, we can do now equal calling the time package and then calling the now method. This will give you the current time. So we can do fmt println now. Let's now run our program to see what the output looks like. And as you can see, it gives you the current time with time zone information and monotonic clock readings. Now let us calculate the time 2 hours from now. So I can say 2 hours equal to 2 into time dot hour, which is a constant again. Now I can say future time is equal to now dot add 2 hours, and that should give you 2 hours in the future. Let us now run our program to see the output. And as you can see, 2 hours were added to the time or the current time. That is 8 o'clock, it went to 10 o'clock. Now let us use some other methods on time. You can do something like this where we say start is equal to time dot now, which will give you the current time, and then let us run a loop. Let me first initialize a value of a to 1, then we can do a plus plus. Now we can check the elapsed time by using the since method and do time.since and provide a start. So this will give you the elapsed time or the duration of running this code. Then let us print the elapsed time. Now let us run the code to see what we get. Go run main.go, and as you can see, it gives you the loop execution time, which is 3.089 milliseconds. That's basically how you would use time in general. I would highly recommend you to go through the time package docs to understand different uses and use cases. Let's now summarize everything we have learned in this lesson. We saw that the standard lib package time provides all the functionality you need to work with time in Go. It provides you the time.time and time.duration types, which are the two major constructs of working with time in Go. You will see that when we build projects, we will be using time all the time. No pun intended. That's it for the lesson. I hope you liked this video. If you have any questions, please post a comment under the video or reach out to our Discord server. Thanks for watching. Until next time, happy coding.